I'm just going to go ahead and roll. Yep. Okay, thank you.
So, enough of that. A little more about me, about why I'm giving this talk. For the last 9 years, I've worked at a hospital in IT, or in Fairbanks, and at the hospital is not an enormous infrastructure, but it's very 24/7. It doesn't get much more 24/7 than a hospital and these clinical systems that we've been putting in. So I've had my hand in a lot of different systems and have used Nagios to improve the situation with them. Before I was at the hospital, I was a web developer, and actually in the last couple of years, I've moved back into web development at the hospital. So I have kind of a foot in both the system administration and development worlds. The central idea that I want to talk about and dwell on and explore with you is that monitoring tools are to the system and what testing tools are to the developer. I have kind of thought that way for several years, but this year I started kind of exploring that idea, and I think there's a lot of fruitful work to be done in that area, and hopefully you can use something from this to improve the quality of the service that you're offering. Trying to figure out how to do hyperlinks in a presentation like this, and I decided this is the best way. This is the short URL for a blog post I wrote this summer on this topic. It goes into more detail than I can do now. And there will be a few more of these. If your camera likes those QR codes, you can try it. It may not work the first time typing it out. It usually works the first time or the second time. So we're going to talk about what test-driven development is and where it has come from the software development world. Then we're going to try to make the translation into the network and IT infrastructure monitoring world of Nagios and compare the test-driven approach to the monitoring environment, translate it. Then we're going to look at some sample tools that I've written or found to take this idea further, and finally suggest some additional ideas. So first, an introduction to test-driven development. The software engineering world was not the first to be concerned about quality or quality assurance. There's a long tradition of quality assurance, especially connected with manufacturing. So there are these things like the UK's Institute of Quality Assurance that produce definitions like this. In its broadest sense, quality is a degree of excellence, the extent to which something is fit for its purpose. In the narrow sense, product or service quality is defined as conformance with requirement, freedom from defects or contamination, or simply a degree of customer satisfaction. And they make the point that quality is judged not by the producer, but by the receiver. So it doesn't matter if everything is pingable. If the user judges that the quality is low, that's what matters. How do you get quality? That's what quality assurance always tries to do. You verify that the essential functions are there, and you hopefully screen out the defects before they are delivered to the customer. Software engineering has a harder time than other disciplines at doing this. We've all experienced that. And I think it's no wonder. I know Douglas Crockford has said that software is the most complicated thing that humans produce. Think about that. It's probably true when you think about all the layers that go into making Microsoft Word crash. It's pretty complicated. So the software world has approached testing at different levels, and there are a lot of different competing terms and approaches to testing. I'm going to focus on these three. There are other names and there are overlapping definitions, but these are in order of abstraction. So unit tests are very specific, testing one single unit of software and measuring whether it behaves as expected. They're low level. Integration, oh, actually, here we go. And unit tests are usually expressed in a way that they have a yes or no answer. Integration testing puts the units together and tries to measure whether or not they're working together. Sometimes the answers are more complicated than yes or no. Sometimes you might be measuring performance and things like that at this level, and so you need to get into ranges. The difficult thing about integration testing in the real world is that if you have a test environment, you never have all the conditions of the real world. You have to have a whole parallel universe to really simulate reality. So there's always a difference between test and reality. And then at a higher level still is user acceptance testing, also called functional or customer testing. And that asks the question, does it work for the actual user? Does it do what the user needs to do? It focuses on user stories. And an example of a user story that actually can be used in some test frameworks is as a user closing the application, so that kind of lays out the assumptions. I want to be prompted to save anything that has changed since the last save so that I can preserve useful work and discard erroneous work. And you can run that test and verify whether or not it behaves as expected. Now, anybody who's worked on a program has done the old-fashioned developer hand method of running it and watching it crash, and then running it again and trying and hoping it won't crash, and then and then running it again and giving different input and trying it out and saying it basically works. But there's a problem with that, and that's that developers, especially after the 18th time of filling in all the form fields to make sure they validate, we start taking shortcuts and we're lazy and imperfect, and so we need robots to do it for us. And by automating our tests, we can get more thorough and consistent and fast results. We can make it more likely to fire off a test script that exercises the application than I am to actually go and click through all the user interface elements. It also gives us a scoreboard, and we can rig the results, right? So hopefully we're always winning because we're always passing our tests. So the extreme programming movement sort of around the turn of the century, decided to look at everything that was good about software development and do it more. And they said, well, testing is good, so let's do it more. Let's do it early. Let's actually write the tests before we write the software. That way, we know when the test passed that the software is done. Let's test always. Let's write those test scripts and run them continuously every time we make a change. And that's often continuous integration. Anytime the source code changes, let's run the whole test suite. And if anything fails, then we'll make the siren go on, or the lava lamp turn red instead of green. Or plugins exist for continuous integration products that hook it up to various USB devices or whatever to give you real-time feedback. We have one of these missile launchers, but we haven't yet hooked it up to Nagios. One of those rainy day projects. That'd be pretty cool if it knows who, the contact group, who needs to be fired upon. A more recent trend in the testing world, software testing, is behavior-driven development, which it doesn't replace or supersede anything about test-driven development. It's a renewed focus on the user's end of things. Instead of starting at the unit test level, behavior-driven development starts at the user level. It doesn't ask, did the addition object add the numbers properly? But it asks, can the cashier complete a sale? And so it starts at that user story level. One benefit of that is that you can negotiate with your users a good set of user stories. And then when all of your user stories pass, then your software is done. And when your user says, but it doesn't do this, you can say, well, did we have a user story for that? Let's write one, let's negotiate, and so forth. So that's